This video is to review addition and multiplication with decimals. There's been some confusion about the difference between the two and where the decimal goes, and I wanted to make sure that's clarified. So let's look at two sample problems. First, we have 1 2/10 plus 3 7/10. The first thing we're going to do is we're going to take the problem and we're going to try to solve it vertically. I don't want you to do it horizontally yet. So we're going to start with 1.2 plus 3 7/10. Okay? Notice what I'm doing here is I'm lining up the decimal. Okay? So in my solution, I'm automatically going to put a decimal there. That's one of the important things that you must note with addition with a decimal. Line up the decimal, bring it down. From there, I can start solving. So 2/10 plus 7/10 is 9/10. Decimal's already there. 1 plus 3 is 4. So my solution, or the sum, is 4 9/10. If I take the next problem as another example, 1 2/10 plus 37, it's going to look similar but not be exactly the same. I'm still going to do it vertically, so I'm going to write my 1 2/10, and then I'm going to add 37. Now it's important to remember that I need to line up the decimal. Now if I have 37, the decimal comes after the 7. So I'm going to write the 3 in the tens place, the 7 in the ones place, add a decimal, and add a 0, because I have 0/10. If you'd like, you may add an extra 0 in the tens place here, because there are 0/10s and 1 2/10. If that's confusing, or if you understand it without it, that's fine too. And then I will add it together. Once again, I'm going to do the decimal first. Okay, 2/10 plus 0/10 is 2/10. 1 plus 7 is 8. 0/10 plus 3/10 is 3/10. Looking at these two problems, I have very different solutions. I have 4 9/10 and 38 2/10. That's a difference of over 30. So you can see that lining up the decimals does make a huge difference. Okay, let's look at another problem. This problem is similar. We have 1 2/10 plus 3 9/10. So we're going to start by writing our 1 2/10 plus 3 9/10. Okay, so it's still lined up. The decimals are still lined up vertically, and I'm going to start by writing the next one. Okay, and I'm going to have 2/10 plus 9/10. We need to remember that 10/10 is the same as 1 whole. So if we have 11/10, we really have 1 whole and 1/10. So what we're going to do is we're going to take that 1/10 and we're going to bring it down. And we're going to carry over that 1 whole to our next part. So we're going to have 1 whole plus 1 whole, which is 2 wholes, plus 3 wholes, which is 5 wholes. So our sum is 5 1/10. Now, this addition is different than multiplication. Say that we have 1 2/10 times 37. For this problem, we're going to line up the numbers, not the decimals. So we have 1 2/10 times 37. We're going to worry about the decimal at the very end. Okay? So we'd have 7 times 2/10, which is 14/10. So we're going to have our 4 here, and we're going to carry the 1. 7 times 1 is 7, plus 1, which is 8. Okay, and then we're going to go down to the next one. We're going to cross off our 7 because we don't need that set of 1s anymore, and we're going to draw our 0 to remember that we don't use that place value anymore. 3 times 2/10 is 6/10. Okay, and 3 times 1 is 3. And then I'm going to add down. I have 4, 14, carry the 1, and 4. Now I know if I estimated that 1 and 2/10 would round to 1, and 37 could round to 40. And 1 times 40 is 40. So 444 does not make sense as a solution. But what I need to do is remember that I have my decimal here, and I have 1 digit in a decimal place. So I'm going to have 1 decimal in my product, which is 44 and 4/10, which if I look back at my estimate, 40 is pretty close to 44 and 4/10, so I know that's about correct. I'm going to put that to the side, and we're going to try another problem that looks very similar. We have 1 and 2/10 times 3 and 7/10. I'm going to write it the same way, but don't forget I have a decimal in each of those. Okay? When I solve it, the numbers are going to look the same. Okay? Before I put in the decimal, I get that 444 again. Okay? Remember how we had that over here before we did our decimal. So we can estimate again. 1 and 2/10 is going to round to 1, and 3 and 7/10 can round to 4. So I know my solution is going to be about 4. Okay? If I have 444, I can look back and remember I have 1 decimal, 2 decimals in a decimal place. So I will have 2 decimals here, okay, which is 4 and 44 hundredths, which is close to my estimate of 4. If I counted wrong and I got 44 and 4/10, I need to look back at that estimate and say I made a mistake somewhere and go back and check and see where that mistake was made. Try this next one on your own. 2 and 46 hundredths times 1 and 3/10. It is a little bit different than what we've been doing, but I want you to try it. Pause the video, and then I'll show you how. Alright, when I write the problem, I find it easiest to write the number with the most digits up top, and then the number with the fewer digits on the bottom. Notice I did not line up the decimals. This is not an addition problem. I don't need to have those lined up. Then I will solve it like I normally would. Okay? When I multiply it out, I start with 3/10 and then multiply each of the top numbers by 3/10 to get my first column, or first row, excuse me. Cross it out and move on to the 1, and the 1 gets multiplied. And then here I'm just going to add everything straight down. When I add, I get 3,198, but that doesn't really make sense. Okay, so I'm going to estimate 2 and 46 hundredths is close to 2. 1 and 3/10 is close to 1. So my solution is going to be close to 2. So it wouldn't make sense for me to have 31 and 98 hundredths or 319 and 8/10. It would make sense for me to have 3 and 198 thousandths. Again, if I look at it, I have 1, 2, 3 digits following a decimal. I have 1, 2, 3 digits following the decimal. Okay, I hope this helps. If you have any questions, let me know.